In this video, we're going to do a quick review of all the different things that we've learned about graphing exponential functions so far. So the first one here says determine the y-intercept of the following function, and it gives me the function y equals 1/2 times 1/5 to the power of x minus 2 plus 6. And what we want to do to find the y-intercept is sub in x equals 0. Because if you think about the y-axis on a graph, which is right there, all of the points on that axis are all going to have an x value of 0. So we're going to take our function 1/2 and then times 1/5 to the power of 0, take away 2, plus 6. So order of operations says we start with brackets. So we're going to simplify what's inside this big bracket here first. And then inside there, we're going to do our exponents. So 0 take away 2. I get 1/2 times 1/5 to the power of negative 2. That second bracket is really redundant, but I'll keep writing it down anyways. A negative exponent makes a fraction, and it has a flipping over action. So that 1/5 is going to flip itself over and become 5/1, or just 5 to the power of 2. Now 5 to the power of 2 is 25. So I have y equals 1/2 times 25 plus 6. Now I could use a decimal here, but I really would like to try to keep it a fraction if I can. So I'm going to multiply 1/2 times 25. 25 is secretly 25 over 1. And when we multiply, we do numerator times numerator. So 1 times 25 is 25. And then denominator times denominator, 2 times 1 is 2. Now I could write plus 6, but I think instead I'm going to try to get that over denominator of 2 as well, so that it's ready to go when I want to add. Now this 6 is also secretly over 1, and to turn that 1 into a 2, we're going to multiply the bottom by 2, and we're also going to multiply the top by 2 to give us 12 over 2. And then all I need to do to finish off here is just add together 25 over 2 and 12 over 2, which is 37 over 2. So my y-intercept is 37 over 2. Now the next part says determine the horizontal asymptote of the following function, and I have y equals -5 times 6 to the power of x plus 7 minus 3. So the horizontal asymptote we learned comes from that number right there. So this actually is just going to be y equals -3. All right. Question number 3 says graph the following function using transformations. So I have y equals -3 times 4 to the power of x minus 5 plus 6. And you'll notice that the table has a place for the base function and a place for the transformed function. So the first thing you want to do when you're making a graph is you want to figure out what your base function is. And you can identify the base function because it's the one that has the exponent on it. So my exponent is here, it's the x minus 5. So the thing that's holding up the exponent is the 4, which means that my base function is going to be y equals 4 to the x. So I am going to start by doing a table of values for y equals 4 to the x. I like to start at the bottom. I find that a little easier. So 4 to the power of 4 is 256. You can use your calculator if you need to, or your power sheet. 4 to the power of 3 is 64. 4 to the power of 2, 16. 4 to the power of 1 is 4. Anything to the power of 0 is 1. 4 to the power of -1, a negative exponent makes a fraction. So if I look at 4 to the power of +1, which is 4, I'm going to turn that into a fraction and say that this is 1 over 4. 4 to the power of -2, I take a look at +2, which is 16, and I make it a fraction, so it's going to be 1 over 16. -3 is going to be 1 over 64. and negative 4 is going to be 1 over 256. All right, to do the second part, we want to look at the transformations of our function. So when I take a look, I see I have a 6. I have that minus 5 in the bracket there. I have the minus 3. And I do have the 4, but the 4 is not a transformation. The 4 is the base. So I'm going to start with the plus 6. That plus 6 is going to take the graph and move it up 6. The minus 5 is going to go left, nope, right. 5, it always does the opposite of what you would think. So a plus would go left, a minus goes right. Now in the front, I have not just a 3, but a negative 3. So the negative is a reflection. And the 3 is a stretch, a vertical stretch of 3. So we're going to take our function, we're going to take our table of values and figure out which of these affect the x and which of these affect the y. So if I'm moving up 6, that is changing the y values, and we're just going to add 6 onto them. Right 5 is going to change my x values by moving it to the side. Now, it's a minus 5 in the bracket, which tells me I'm going to do the opposite and add 5 here. And then the reflection and the vertical stretch of 3, we do those together. So when I'm stretching, I multiply. When we're compressing, we divide. So since it is a vertical stretch, it is going to change the y value. And we are going to multiply the y value by 3. And since it is a reflection, to make it a little easier, we're just going to multiply by negative 3. So I'm going to take my table of values for the base function, and all of my x values I'm going to add 5, and to all of the y values we're going to multiply by negative 3 and add 6. So negative 4 plus 5 is 1, negative 3 plus 5 is 2, negative 2 plus 5 is 3, negative 1 plus 5 is 4. I'm definitely seeing a pattern here, but I always check the last one just to be sure. 4 plus 5 is 9, which is good. Now to do the other one, I will often use my calculator to help me out, since sometimes it's a little tough to do that in your head. I'm going to zoom out a little bit here. So I have 1 over 256. We need to multiply first before we add and subtract. You have to follow those BEDMAS rules. So 1 divided by 256 times negative 3 plus 6 is 5.988 or 5.99. 1 divided by 64 times negative 3 plus 6 is 5.95 approximately. 1 divided by 16 times negative 3 plus 6 is going to be 5.81 approximately. 1 divided by 4 times negative 3 plus 6 is 5.25. All right, 1 times negative 3 plus 6 is 3. 4 times negative 3 plus 6, why do I keep hitting that one, is negative 6. 16 times negative 3 plus 6 is negative 42. 64 times negative 3 plus 6 is negative 186. And 256 times negative 3 plus 6 is negative 762. So what I want to do is plot those points on my graph. I don't need to graph the pink ones. Those were just the base function to help me figure out these ones. So we very rarely graph the base unless it asks for it. We generally just graph the transformed function. So I am going to zoom out a little so that I can see my grid a little bit better. I find it a little bit easier if I mark on a scale. I don't even have to always put numbers, but if maybe I put tick marks on at the 5s, it just makes it a little bit easier to find points when you're looking for them. Okay, and I could mark the numbers if I wanted to, but I think we're going to try it without this time. We'll see how that goes. So I am going to plot the points. I'm going to start at the bottom. I have 9 and negative 762. On my graph, I can go to 5, 10, 15, 20, negative 25 total. So that's not going to go on the graph. Neither is the negative 186 or the negative 42. But I can plot 6 and negative 6. And then 5 and 3. 4 and 5.25, so it should be a little bit above that 5 mark. 3 and 5.81, that's going to be closer to the 6. And then 5.95 is going to be even closer to 6. And 5.99 is going to be really close to 6. So I see that one side should look vaguely like a parabola. And then the other side is going to level off at my horizontal asymptote, which I can tell from the table is going to be 6 because these numbers are getting really close to 6. I also know that it's plus 6, so that has an asymptote at 6 there. Now there is one more page to our lesson here, and it's an application problem. The question says, during a science experiment, a chemical substance is monitored over 50 hours and its mass is recorded. The graph is shown below. So on the graph, very small and hard to see, but it says time in hours on the bottom and mass of the substance in grams on the side. So the first one says how much of the substance is present at the beginning of the experiment. So the experiment would have started at time equals 0. So you look on your graph at time equals 0, which would be where the graph starts. And according to my graph, it looks like there was roughly 100 grams of the substance to begin with. All right, the second part says approximately how much of the substance is remaining after 4 hours. So to do this one, what I want to do is take a look at my graph, find the 4-hour mark, which would be the line just before the 5, and then I'm going to follow that up until I hit the curve, and then I'm going to follow that across, and to me it looks like roughly 60 grams would be remaining after 4 hours. Okay, the next one says after how many hours is there approximately 88 grams left? So this time it is 88 grams, not 88 hours. So I'm going to look on my graph for 88 grams. Now I notice that there are only 5 squares between 80 and 90, which tells me every one should be worth 2. So 88 would be there. So if I follow that across, that really is just that first grid line at 1. So it, in my opinion, would take 1 hour. All right, and the last question says, what is the half-life of the substance? Half-life is how long it takes for there to be half of the amount remaining. So one of the easiest things to do is to take the starting amount, which was 100 grams, and figure out what half of that would be. So 100 divided by 2 is 50 grams. So half of 100 is 50 grams. So if we started with 100 grams, I want to find how long it would take until there were only 50 grams. So 50 grams is right here. I follow it across. You see that I'm halfway in the middle of a grid line. So that tells me that this should be 5.5 hours. Oops, you can't see that. So I'm going to say 5.5 hours. All right, so what you need to do is to do the check your understanding page on your own, and then we will take that up in class.